so far we've looked at finding the pH of strong acids and strong bases. We've also looked at finding the pH of weak acids and therefore acidic salts like ammonium chloride. What we're going to look at now is if we had a weak base. This is taking those ideas and bringing them all together. So there's a lot of knowledge we need to have before we can actually really attack these. And I'll put these with red bullet points next to them. The first thing is we need to understand Kw is not just hydronium times hydroxide, it's also Ka times Kb. And Kw is a magical number, as it were. At room temperature, 1 atmosphere pressure, what is the value for Kw? Sorry, 10 to the minus 7 would be what each of these would be. So this is 10 to the minus 14. Cool. So that's a number we have to know. We just have to know that that's 10 to the minus 14. So that's another one I could have put as a bullet point as well. That Kw is 10 to the minus 14. Another way to think of it is pKw is 14. So remember we used to say that the pH scale was a 0 to 14 scale? That's why we said that, because the pKa plus the pKb is 14. So it's another thing you could use to help remember it. It makes some of the maths in this a little bit easier. So another way to think of that is also pOH plus pH plus pOH will also equal 14. Now, when we are looking at a base, we can generalise base as a capital B, just like we called acids HA. We put the H in it for acids because they lose H+. So if we say that B is our base, we can show that base being put into an aqueous solution to justify why it is a base. Bases will have a higher concentration of hydroxide ions than hydronium ions. So if we can show an equation that makes hydroxide ions, we know that we've got our starting point for working with bases. With a strong base, this would be an arrow, not an equilibrium system. And so whatever the concentration of our base, we'd end up making that concentration of hydroxide ions. Then we can find our hydronium ion concentration using this, and then find our pH. The problem is that a weak base doesn't do that. A weak base only partially dissociates. So we don't really know how much hydroxide is being made. And so we're going to have to find that out a different way. So we write an equilibrium equation, and then we write an equilibrium expression, just like we did with weak acids. The difference is we're working with hydroxide ions now, not hydronium. That's the only real difference. The other real annoyance is you're given a Ka or a pKa for the conjugate, so it's conjugate acid. You're not given a pKb or a Kb value. So you have to work it out. And that's why this, or this, whichever you prefer to use, is so important for you to know. So, I've given an example here. We've got ammonia and an ammonia solution. So the ammonia has been dissolved in water. So I show that with this equation. I'm going to make the assumption that the ions that are produced are in the same concentration because they're in a 1-to-1 ratio. The nice thing is in level 3, you're only going to be throwing things in a 1-to-1 ratio. Okay, so you're only looking at first proton transfer, not any more than that. So I write a Kb expression for this. Notice that it's Kb, not Ka. Because it's got hydroxides, it's Kb. Because it's got hydroxides, it's a base, so it's Kb. Alright, so that's what the B actually does stand for. So we're not being tricky or clever. So let's say that the question was, find the pH of 0.415 moles per litre ammonia in aqueous, meaning dissolved in water. My first step would be to write my equation, if it's not given to me already. My second step would be to write a Kb expression, noting that we've got hydroxide in there. My third step is actually going to be to use one of these, depending on whether my mind works better with pKs or with Ks, to work out the Kb, because I don't have a Kb in this. I've got a pKa of what's made. So, if I know the pKa, I can find the pKb. So how do I rearrange that so I can find my pKb?
Make it equal to pKw.
Oh, cool. So I could go... Okay, there's two ways to do it. The one I've got on the board is I've gone the first one, kW, which is 10 to the minus 14, divided by 10 to the minus 9.24. So I've turned this number into a Ka value. Or, if I'm better working with P values, I can go pKW is 14, so it's just 14 minus the pKa will give me the pKb. So 14 minus 9.24 is 4.76. And then I go, how do I undo a P value? It's 10 to the power of the negative whatever it was. So it would be 10 to the negative 4.76. So I can use either of those two to get to the same answer. Alright, so that's your first thing. Your first step is to find the Kb value. Kb value from the Ka or pKa. Alright, so if we struggle to do that, then it's probably a question we need to skip past, to be honest. We just need to write down what we can, a Kb expression, and maybe stop there for now and come back to it later. Alright. Once we've got this value though, things become a lot easier, a lot more familiar, become a lot easier. Because I put that number into here. I've said that these two are the same, so that means I can make it hydroxide squared, because I can work with hydroxides. There's a relationship between hydroxide and hydronium, and therefore a relationship between hydroxide via hydronium and pH. So, I rearrange it so that it now says, this thing here now says 10 to the minus 10 to the minus 4.76 equals hydroxide ion concentration squared, because these are the same. So I can choose which one it is. I'm going to choose this one. And my other one is very similar to my assumption that I made with weak acids, that it's not going to dissociate much at all. So because I don't think it's going to dissociate much at all, I'm going to say that this value here is just the number here from the question. So I'm going to put that down there. Okay. I can rearrange that. This is hopefully going to start to look a bit familiar. Where my hydroxide ion concentration, bases, hydroxide, acids, this would say hydronium, is equal to 10 to the minus 4.76 times 0.415. So the square root of those. And I did this before you came in. That comes to 2.69 times 10 to the negative 3 moles per litre. Now that's hydroxides. Hydroxides don't give me pH. They give me POH, or they give me my hydronium ion concentration by doing some calculations. So you can see why these are excellent questions, can't you? The next thing you have to remember to do is what to do with that number. So I've got my Kb, which has allowed me to get my hydroxide concentration. Now I've finally got that, I have to do something else with it. So I take that number and I put it into this expression here. So I end up with that rearranged as my hydronium ion concentration, which I don't know it, equals Kw, 10 to the minus 14, divided by that answer that I had. This gives me 3.72 times 10 to the negative 12 moles per litre. Again, did that before you came in, so don't think I'm being magical there. Which is a thing I can work with. Once I know the hydronium ion concentration, I can plug that into this equation to find that my pH is 11.4. These are excellent questions because there are so many steps you have to remember to do. So let's just go through it again. Step 1, what do I write? So here's my question. What do I write down absolutely first so I can understand the chemistry that's happening in there? For some of you, you'll do it in your mind. For some of you, you'll write it down. Equations. So that's this one here. From that equation, step 2, what should I write down? Not Ka, because it's a base question. Kb, cool. Third step, done. You haven't given me a Kb in the question. How dare you? What's step 3 going to be? Calculate Kb. Great. Now I've got Kb. I can rearrange step 2 with some numbers in it, which is what this one is here. To solve for what? Fantastic. Concentration of hydroxide ions. Because it's a base, we care about hydroxides. Now the rest of it is like working with a strong base because you've done this process before. But let's see, step 1, step 2, step 3, step 4, so on step 5, now that we've got that, is going to be to calculate the what? Hydronium ion. Good. Using what value? Kw. Awesome. And step 6, we're there for excellence now because we were able to work out the pH from that value. So this is why it's worth, it's given quite a high importance, because you have got 6 steps you have to get right. Now the first 2 you might be able to do in your head, and you get very familiar with it, but the rest you probably need to write down, because you could make calculator errors there and you want to still get credit for your working. Okay, so the first 2 you can do in your head quite easily, but after that make sure you're writing them down.
Do you use rounded, unrounded numbers for calculation?
Good question. Try not to round off if you can help it. Sometimes you're just going to have to use a number. So my suggestion would be write it down to 5 significant figures on your paper, and then in your final answer round it off to the correct number, which will be 3 almost every time. Yeah, I'd write 5 significant figures down on the bit of paper. Okay. Any other questions on that? Okay. Now, this isn't just bases. This is for the salts made when weak acids react. So when a weak acid were to react with, say, sodium hydroxide, then the salt being made will be alkaline. So it's also for alkaline salts. It's not just for true bases like ammonia and things like that. So just be aware of that.
So when it is a salt, do you still use like Kv as the definition?
You do, yeah. So let's say, I'll just quickly grab another pen. An example would be sodium ethanoate. And sodium ethanoate has the ethanoate ion in it. So I'm not going to do states of matter just for pace. If I react that with water, the water loses hydrogen to make ethanoic acid. Okay, so that sodium ethanoate or potassium ethanoate or whatever, that is you can see it's an alkaline salt because it makes hydroxides. Okay, and you'll notice that its conjugate acid is indeed an acid. And so therefore in that question you'd get the pKa of ethanoic acid to work with. The biggest trap is that because you're given a pKa, people tend to write the equilibrium being Hb, so ammonium plus water making hydronium ions in ammonia. That's the biggest trap. You won't be able to solve it if you do that. So you want to be writing it acting as a base, not its conjugate acting as an acid, because that's incorrect. Alright, so just be careful with that, because you end up with 2 unknowns on the same side that are not equal. Alright, cool. Any more questions on that? Awesome.